Good afternoon, everyone. We are going to start with a new topic or a new lesson today, and the name of the lesson is called Aromatic Progression. Aromatic Progression. Let's define what an aromatic progression is. So an aromatic progression is a list of numbers, a series of numbers, or is a sequence of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So that's the definition of arithmetic progression. So the definition of arithmetic progression is also given in the textbook. You can always see that. This is another way of defining arithmetic, what arithmetic progression is. So you take an example, 5, 10, 15, 20, 25. So these are multiples of 5, and if you look at the series, you will see that the difference between 5 and 10 and 5 is 5, and 15 and 10 is again 5, 20 and 15 is again 5, 25 and 20 is 5. So the difference all along the series would be 5. So you can predict the next number after 25. It should be 30, so and so on. So every time you obtain the next number by adding 5 to the preceding term, that's the previous term. So if you think 5 is the first term, then the next term 10 is obtained by adding 5 to the first term, which is 5, so it becomes 10. So to get 15, you have to add 5 to the previous term, which is 10. So 10 plus 5 is 15. So there exists a common difference between two successive terms. So normally we represent the first term by A, small letter a, and the common difference by D. So let's see the general form of an arithmetic progression. So A is the first term, so the next term will be obtained by adding the common difference, which is D. We're denoting the common difference by D, so A plus D. That's the general representation. Then the next term, the third term, will be A plus 2D. The fourth term would be A plus 3D. And if you continue, the last term or the nth term will be obtained by A plus n minus 1 D. So that's the nth term, or we call it the last term. So where A is the first term and D is the common difference. So nth term of an AP is denoted or is given by an equal to A plus n minus 1 D. Some of you might wonder why n minus 1 D. So as we progress to the next part where we derive the nth term, you will understand. So moving on, to find the nth term of an AP, let us consider an AP with the first term A and common difference D. Then the first term will be equal to, it will be denoted or it will be represented by A1, which can be written as A plus 0 into D. So 0 into D, I'm moving the cursor to the position. So 0, actually A1 is equal to the first term, which is A, so that can be written as A plus 0 D. 0 into D will anyway be 0, so that can again be written as A plus 1 minus 1 D, because this one represents the position or the nth position of the term. So here this one and this one are the nth position, or it gives us the position. So for the first position, it will be 1 minus 1 D. Moving on, the second term, which will be denoted by A2. A2 can be written as A plus D. This is the second term. So D, now if you look at it, A plus now this 2, which is the nth term, for this term, for the second term it will be 2. So 2 minus 1, I'm putting the cursor where I am explaining. So 2 minus 1, so 2 minus 1 is going to give you 1. So 1 into d is 1. So a plus d equal to a plus 2 minus 1 d. We are actually trying to derive the nth term. So let's go to the third term to see what we have. So the third term equal to a3, so a plus 2d. So in the third position, or for the third position of the term, it will be 2d. So now how do you get this 2d, and how do you relate it with the nth or the third term? So here a plus this 2 can be written as 3 minus 1, 3 minus 1. So this 3 minus 1 gives you 2. So a plus 3 minus 1 d. Let's check the fourth term as well to get a better idea. So the fourth term is denoted by a4 equal to a plus 3d. So now again 3 equal to 4 minus 1d. So it will, the process will continue. So for the position of the term, if it is the fifth term, a5, then this will be a plus 4d, which will be a plus 5 minus 1d. So it will continue, and when you are to write an, so the nth term, it will be an equal to a plus n minus 1d. So an equal to a plus n minus 1d. So this is how you get the nth term of an AP. Sometimes we call it the last term. More or less it's the nth term. So let's take an example to check whether a given sequence or series is an AP or not. So here I have a question to check whether a given, this is a series or a sequence, 2, 6, 10, 14. So to check whether a given series or a given sequence is in an AP or not, what are you to do? You are supposed to check the common difference. If the common difference does not exist, the given sequence is not an AP. So here 2, 6, 10, 14. So the first term, as you can see, is 2. So that's a equal to 2. Then let's see the differences in the next or in the preceding terms. So a2, which is 6, and a1. This is the a1. The first term is a1. So 6 minus 2, we have it here. 6 minus 2 equal to 4. Then again, this is the third term, which is 10. A3 minus the second term, 10 minus 6, again 4. So it will continue likewise. And as you can see, there exists a common difference of 4 between the successive terms. So this shows us or tells us that the given series 2, 6, 10, 14 is an AP. So that's one example. You can try exercise 6.1, question number 1, and check whether the given sequences are AP or not. And I expect that you would submit the or you would send me the assignments. So exercise 6.1, question number 1. So and on the following day, then we're going to pick up the exercise and different types of questions. I'm going to talk or discuss about different types of questions as well. So that will be all for today.